In this video, I'm going to be going through some practice problems on converting within the mole system. So the first one that we're going to look at is converting from moles to atoms. So the question asks, how many atoms are in 3.8 moles of iron? Okay, so we're going to use the ladder system that we used before whenever we were doing conversions at the very beginning of the year. So we're going to start out by writing what we're starting with, including the units, and put it over 1. So I'm going to start with 3.8 moles over 1, okay, and we're going to multiply that by a conversion factor. So if we're going from moles to atoms, in our sign notes we saw that 1 mole is equal to Avogadro's number, which is 6.022 times 10 to the 23rd. Okay, so because I had moles up top, remember that whatever we have up here has to drop down in order for them to cancel so that we're left with atoms. Okay, so because I had moles here, I put moles down here. In 1 mole, there's 6.022 times 10 to the 23rd atoms. Okay, so I'm going to multiply across the top, multiply across the bottom, and then divide. So 3.8 times my 6.022 times 10 to the 23rd, and then divide that by 1. Okay, just as a reminder on calculators, all calculators are different. This is just kind of like an Apple version of a calculator. If you turn your phone to the side when you're in your calculator app on an Apple device, it'll look just like this calculator here. Okay, if I'm going to put in these numbers, okay, so let's say I'm going to do my 38 times my 6.022 times 10 to the 23rd. I generally like to put in the scientific number first, so 6.022. Okay, and then in order to get the times 10 to the 23rd, the times 10 is the same as this EE button. So EE, okay, 23. Okay, so this number here that you see, 6.022E, the lowercase e stands for the times 10 and then to the 23rd. Okay, so in order to get that, I had to push the EE button, and then I'm going to multiply that times 3.8. Okay, and my answer is 2.28836E, which is times 10 to the 24th. Okay, so I'm just going to round this to 2 decimal places so that I get 2.29 times 10 to the 24th. So if I look back, that's exactly the answer that I got. Okay, and then don't forget to put your units as well. So I'm getting atoms of iron in this case. Okay, when converting from atoms to moles, it's very similar. We're just kind of going the opposite direction. So the question is, how many moles would 3.89 times 10 to the 24th atoms of zinc make up? Okay, so again, setting up my ladder, I'm going to start with what I know. So I know that 3.9 times 10 to the 24th atoms, put that over 1. Okay, because I have atoms here, I'm going to need to drop the atoms to the denominator, and my moles, which is what I'm trying to get to, is going to be at the top. So remember, again, 1 mole is equal to that Avogadro's number, right? So I set that up. I'm going to multiply across, and then divide. So in this case, I'm going to be taking this number here, divided by Avogadro's number, and I'm going to get 6.46 moles of zinc. When we're converting moles to grams, we need extra information. Okay, so remember that the mass of 1 mole of any element can be found on the periodic table. So it's just the atomic mass. So we've talked about atomic mass before as AMU, but we can use that number, that atomic mass number, to represent the amount of grams that the mass would be for 1 mole of that substance. So if I were to measure out 6.022 times 10 to the 24th atoms of gold, it's going to have that exact atomic mass number that we see on the periodic table. Okay, so what would be the mass of 2.7 moles of gold? So again, I'm going to start with what I know. So 2.7 moles, put that over 1. Okay, because I have moles up top, moles need to be on the bottom. okay? And then I will look on the periodic table for the mass of gold in 1 mole. So I'm going to have 1 mole on the bottom is equal to 196.97 grams. This number is directly off the periodic table. Okay, again, I'm going to multiply across, and then divide. So I'm going to get 531.82 grams of gold. Okay, so going from grams to moles, it's exactly the same. We're just going to be flipping that conversion factor because we're going to be going the opposite direction. So how many moles would 33.25 grams sample of iron be? Okay, so starting with what I know, 33.25 grams of my iron over 1. Okay, because I have grams in the numerator here, I need to have grams in the denominator, meaning that the moles are going to be in the numerator. Okay, so when I multiply across, and then divide. So basically, I'm going to be taking this number divided by this number. I'm going to get 0.6 moles of iron. Okay, we do have multi-step converting as well. So if we're going to be going from the mass of an atom or mass of a sample to atoms, or if I have a certain amount of atoms and I want to know what the mass is, we first need to convert to moles, then convert to the desired units. Okay, so in this example, it asks what would be the mass of 8.99 times 10 to the 25 atoms of lead. So if we had this massive amount, this massive number of atoms of lead, what would be the mass? Okay, so again, I'm going to start out by just writing out what I know. So I have 8.99 times 10 to the 25th atoms over 1. Okay, because I have atoms here, I need to drop atoms to here. We don't have a specific conversion factor to go straight from atoms to grams. So first we have to go to moles. So I know that I can use Avogadro's number to convert from atoms to moles. So Avogadro's number, put that on the denominator, and then that is equal to 1 mole. Okay, so now we're in moles, but we're trying to get to grams. So I'm going to take whatever's in the numerator here, so moles is going to drop down to the denominator. So 1 mole is equal to, and if I go down to the periodic table and look at the mass of lead, it's 207.2 grams. Okay, so I'm going to multiply across the top. So I'll multiply this number times the 207.2, divide the whole thing by the 6.022 times 10 to the 23rd, and I'm going to get 30,932 grams that it would weigh.